In Linux, what happens if 1000 files in a directory are moved to another location while another 300 files were added to the source directory? In Linux, what happens if 1000 files in a directory are moved to another location and another 300 files were added to the source directory while original 1000 files were being moved? Will the destination end up being 1300 files? Or will there be 300 files remaining in the source folder?
This depends on which tools you use. Let's check a few cases. If you run something along the lines of mv/path/to/source/path/to/dest/ into shell, you will end up with the original 1000 files being moved, the new 300 being untouched. This comes from the fact that the shell will expand before starting the move operation, so when the move is in progress, the list is already fixed. If you use Nautilus and other GUI friends, you will end up the same way. It will run the move operation based on which files were selected. This doesn't change when new files show up. If you use your own program using syscalls along the line of loop over glob and only one env until glob stays empty, you will end up with all 1300 files in the new directory. This is because every new glob will pick up the new files that have showed up in the meantime.
The kernel itself can't be in the middle of a move 1000 files operation. You need to be much more specific about what operation you're proposing. One thread can only move one file at a time with the rename old path, const char new path, or rename each system calls, and only within the same file system 1. Or Linux rename each 2, which has flags like rename_exchange to atomically exchange two path names, or rename_nor replace to not replace the destination if it exists. For example, allowing a MVI implementation that avoids the race condition of stat and then rename, which would still overwrite a file created after stat. Link plus unlink could also solve that, because link fails if the new name exists. But each of these system calls only renames a single directory entry per system call. Using POSIX rename it with olddiff and newdiff, opened with openo_directory, would allow you to keep looping over files in a directory even if the source or destination directory itself had been renamed. Using relative paths could also allow that with regular rename. Anyway, as the other answers say, most programs that use the rename system call will figure out a list of file names before doing the first rename. Usually using the reader3 POSIX library function as a wrapper for platform-specific system calls like Linux getnts. But if you're talking about find exec ... to run one command per file, or the more efficient exec plus, with so many files that they don't fit on one command line, then you can certainly have renames happening while still scanning. For example, if you created some new .text files while this was running, you might see some of them in ./text files. But internally find1 will have used openo_directory and getnts on . If one system call was enough to return all the directory entries in which find will loop over one at a time, only making further system calls if needed for type or to recurse, or fork plus exec on a match, then the list is a snapshot of the directory entries at one point in time. Further changes to the directory can't affect what find does, because it already has a copy of the directory listing what it will loop over. Probably it internally uses reader3, which returns one entry at a time, but inside glib we know from using strace find that it makes a getInt64 system call with a buffer size of count equals 32768 entries. But if the directory is huge and or the kernel doesn't fill finds buffer, it will have to make a second getInt system call after looping over what it got the first time. So it could maybe see new entries after doing some renames. But see discussion in comments under other answers. The kernel might have snapshotted for us, because, I think, getInts isn't allowed to return the same file name twice. Different file systems use different sorting, indexing mechanisms for making access to an entry in a huge directory more efficient than a linear search. So adding or removing a directory might possibly have other effects on the order of the remaining entries. Probably it's more likely that file systems keep a stable order, and just update an actual index, like the ext4dir_index feature, so a directory FD's position can just be a directory entry to resume from. I really don't know how the telldir3 library interface maps onto lseek, or if that's purely a user space thing for looping over the buffer obtained by user space. But multiple getInts can be needed to get all the entries from a huge directory, so even if seeking isn't supported, the kernel needs to be able to record a current position. Footnote 1. To move between file systems, it's up to user space to copy and unlink. For example, with open and either read plus write, map plus write, or send file to or copy _file range 2, the latter two totally avoiding bouncing the file data through user space.
When you tell the system to move all the files from a directory, it lists all the files and then starts moving them. If new files appear in the directory, they aren't added to the list of files to move, so they'll remain in the original location. You can, of course, program a way of moving files different to MV, which will periodically check for new files in the source directory.